Hi everyone, this is a problem from graphic 3.23. Here, the Hamiltonian for a certain two-level system is H cap equal to E bracket in bracket or in parenthesis we have outer product of 1, then minus outer product of 2, then plus outer product of 1 and 2 and plus outer product of 2 and 1, where these 1 and 2 are orthonormal or orthogonal bases. That means the inner product of 1 will be 1 and the inner product of 1 and 2 will give you 0. Fine, that is the orthogonal basis, and this E is a number with dimension of energy, then finite eigenvalue and normalized eigenfunction as a linear combination of 1 and 2, and what is the matrix H representing Hamiltonian gap with respect to this basis. So they are saying to find the eigenvalue and a normalized eigenfunction. So in order to find the eigenvalue, we can write this Hamiltonian gap as a matrix. So we can do it in two ways. One is like we have H that can be written as a matrix form, H equal to E, then 1 1 1 2 2 1 2 2. Is it? This is the form 1 1. Suppose A11 A12 A21 A22. Fine. So from here we can write E equal to A11 is 1 1. We can write 1 1 coefficient is 1. Then A12 1 2 coefficient is also 1. Then we have 2 1. Is it? 2 1 coefficient is 1 and 2 2 coefficient is minus 1. So this is the matrix, and from there we can find out lambda. Or other way you can write, firstly what they have said, the eigenfunction should be expressed as a linear combination of 1 and 2. So we can write it as psi equal to some constant C1 and a basis 1 plus some constant C2 and a basis 2. Fine. So now we can write H operator operating on psi. This will be giving you some eigenvalue, that is, let it be epsilon psi, right? So firstly we will find this. So H operating on psi, what is the operator value is E, then we have outer product of 1 minus outer product of 2, then outer product of 1 and 2 plus outer product of 2 and 1, right? So this is the Hamiltonian operator. Then we have a psi, where psi is expressed as C1 1 plus C2. Now we will be multiplying these two factors. So when you multiply, we have to keep in mind, when a 1 operates, means one inner product of 1 and 1 will give us 1, inner product of 1 and 2 will give us 0. So no need to write with 1. Means when there will be other two terms like 1 and 2 will be 0. If it is 1 and 1, then that term will exist. So we can directly write here E, right? 1 will operate with 1, means this 1 and 1 will give you 1. So coefficient is here is C1 multiplied by this cat 1. So C1 cat 1. Similarly again 1, when it get inner product with 2, it will be 0. So this factor will get cancelled. Then again C1 operating on this 2, this also will be 0. Only way it will exist in case of 1 and 1, because the inner product of 1 and 1 will give you 1. So coefficient of C1 multiplied by cat 2. So plus C1 cat 2. Similarly in case of this 2, when it operate or when it inner product with 1 will be 0, but when there is an inner product of 2 and 2, it will give you 1. So this contains minus sign, and here is a coefficient is C2, and here you have a cat 2. So you can write minus C2 cat 2. The other one will be 2 and 2. Where is 2? We will find it like here is 2. So inner product 2 and 2 will be 1. So you have C2 here and 1 cat plus C2 1 cat. So now we'll combine this, like E, this is A psi, A is kept psi, then we can write C1 plus C2, is it? C1 plus C2 cat 1 plus C1 minus C2, C1 minus C2 cat 2. This can be written as epsilon psi, right? So epsilon and psi can again be written as C1 1 cap plus C2 2 cap. So from these two, what you can write, C1 plus C2 is equivalent to C1, because 1 and 1 cat we have, and from these two we can write C2 is equal to C1 minus C2. So C1 plus C2 gives you, and here is again one E is there, and here we have epsilon, then we have 1, is it C1s, right? So from there we can write C1 plus C2 will give you epsilon by capital E, that is the eigenvalue C1, or C2 can be written as epsilon by E minus 1 C1, right? Similarly, with the other equation we have E C1 minus C2 equal to epsilon C2. So in that case we can write C1 minus C2, we have epsilon here, E over here, and C2, is it? So this can be written as C1 equal to epsilon E plus 1, then we have C2 over here, right? So here we can replace the value of C1, then we will be getting epsilon E minus 1, and the value of C1 we can write it as epsilon E plus 1, then we have what? C2, right? So therefore, taking this, C2 equal to A minus B, A plus B, so we can write it as epsilon E whole square minus 1 C2, right? So this can be written as 1 equal to epsilon square E square minus 1, that is equal to 2 E square equal to epsilon square, or eigenvalue epsilon will be plus minus 2 E, where E is a number with dimension of energy. So this is the eigenvalue. Now we have psi equal to C1 1 cap and C2. In place of C2, what you can write, we can replace it this. So wait, here you can write, where is it? Yeah, C2 equal to, in place of epsilon we can write plus minus root 2 E. So if you write plus minus root 2 E, E and E will get cancelled and you will be left with root 2 plus minus minus 1 C1. So that will be replacing it here. So in place of C2 we will be replacing plus minus root 2 minus 1 C1. So this gives, let me write it as psi plus minus, because there are two terms involved. Psi plus minus cap scat is important. So here also you can replace with cat. So psi equal to C1 you can take common and will be left with 1 cat 1 plus minus root 2 minus 1, and we left something, I think there will be cat 2. So there will be cat 2. So now we can easily normalize this wave function, because we have a one constant and we can do the inner product of psi plus minus with its complex conjugate psi plus minus, and will be this will be equal to 1, and we can find out the value of C1. So that will be normalized. And the Hamiltonian, what they have asked, what is the matrix H representing the H is a matrix representing the H operator. H is a Hamiltonian operator with respect to this basis. So this is this. So thank you so much. So this is the answer of this. Find the matrix H, right? From there we can find the value of lambda, and that we will get it as this value and plus minus root 2e, and then we'll replacing this value over here, and then you are replacing that value over that wave function or wave vector. We end up here, and then we can normalize it by the cross product, and we can find out the value of C1. So thank you so much.